All right, good morning, everyone. So right now we have 2, 4, 6, 8, 10, 12, 13. So we have a little less than 50% of my period 4 class, so 13 out of 27. So about 47%. You can check my math later, give or take a percent. It's probably pretty close. All right, so first thing, see there's my joke.
Are we supposed to be your laughing reel?
I love you guys. All right, so what we're going to look at is, so I would say you're probably going to want to have graph paper at home. I will have, oh, where's Nicole Dutton? Her paper's not here for me to photocopy. All right, Erica, you're on for the day, okay? Nice and neat, got it? Okay, so what I'll do is we're going to look at 6 different parent functions, and we're going to graph for the next week. Parent functions, we're going to write the equations of parent functions. So I'll give you this note, so it'll come in 2 parts. This will be graph paper. So the one that I give you for notes, the first notes, I will also include Erica Thaler's graphs of this. All right, so first thing, 6 parent functions. So we're going to look at, for number 1, a parent function is something that hasn't been transformed at all. So like for example, number 1, I'm going to call them all f of x. F of x is really just replacing what? Y. So it's same as saying y equals. So the first one is f of x equals x. What type of function is this? Linear. Okay, so I'm going to put it's linear. All right, so I love that my first video, at least I have interaction. This is awesome. All right, so my rest might get a little bit more boring. We'll see from there. So let's graph this. All of the graphs, except for the last 2, I'll tell you when they are going to be 5 by 5 is enough to fit it. So a 5 by 5 grid right now. All right, so y equals x. Where does this graph start out at?
0.
Okay, the origin. Okay, and what's really, so we know it's linear, so it just has slope. So what's this, the slope of the line?
1.
So it's going up 1 over 1. So basically 1, 1's a point, 2, 2. So it's linear, it goes up 1 over 1. Okay, so that's our first, so algebra 1 is mainly linear functions, so we're good with linear. Our second one that we're going to write down, our second parent function is going to be f of x equals x squared. So I'll write the name and I'll put the name of the parent function above it. So we spent pretty much all of our second quarter was this function. What's the name of this function?
Quadratic.
All right, again, 5 by 5 is enough. So go ahead and draw. I'm just for the sake of being able to fit it into this section, I'm going to write small. I'll have graph paper for when we're actually transforming them. So we know how to graph this. Where does this graph start out at?
The origin.
Where do you think every parent function is going to start?
The origin.
At the origin, correct. So what was the stretch of this graph? What's the stretch if it doesn't have a number?
1.
Okay, so think about the pattern. If I went over 1, I went up what?
1.
Over 1, up 1, because it's 1 squared still 1. If I go over 2, I have to go up how many?
4.
2 squared gives me my output of 4. All right, so 2, 4 is a point, and negative 2, 4. So we remember it had symmetry with respect to the y-axis. All right, number 3 I want you to write down is f of x equals the absolute value of x. So f of x equals the absolute value of x. So what do you think the name of this parent function is?
Absolute value.
Oh, you guys are awesome. I can already tell this is my best video. It's going to be my best video throughout the whole time. Unless I find some jokes that,
You just need a button that does laughter.
Ah. Okay, I'll buy a button next time. All right, so again, 5 by 5 is enough for this. Where does this graph start out at?
0.
The origin. the stretch of every single parent function? What is the stretch of every single parent function?
1.
Okay, it has a stretch of 1. So let's think about for this one. What's the absolute value of 1 if I input 1?
1.
So 1 1's a point. What's the absolute value of 2? So 2 2's a point. Okay, so on the other side, let's put a -1. What's the absolute value of -1?
1.
Positive 1, yeah. The absolute value of -2.
2.
So what kind of shape is this graph?
A V.
Okay, absolute value, you can remember, is a V. Okay, quadratic is a U, and then we have linear. Okay, so these are our 3 parent functions so far. What can you see about the quadratic and absolute value?
They're similar.
How are they similar?
They both have 1 term.
Okay, yeah.
They end
Okay.
in the same.
They have the same end behavior, and what also? Okay, what do they have symmetry with respect to? Both of them.
Wait, what's it called?
Y-axis.
The y-axis, yes. They have symmetry with respect to the y-axis. Awesome. Okay, and then we're going to see that actually none of the others have symmetry, only 2 and 3 with the y-axis. All right, so are we okay with these 3 parent functions?
Yes.
Okay. Number 4, we are going to look at f of x. Is it going to equal to the square root of x? F of x equals the square root of x. Okay, what parent function is this called?
Radical.
Okay, this symbol is a radical, and I wanted to change that on that note sheet. What root is this?
2. Square.
Okay, what's that called, Cole?
Square.
Square root. So it's the square root function. Because it does, we can remember we can have a different root. So this is the square root function.
So instead of radical,
I would like it say square root. And I'll correct that on that note sheet, yes. And maybe before I upload it, I'll cross it off. Okay, again, for this, if you can have a 5 by 5 is enough. Okay, so I think to show, because we have not seen what this function looks like, to see this, I'm going to make a little input-output table. We understand this pattern very well. So once we see this pattern we'll also probably see pretty well. And then we'll use the pattern to graph it later on. So tell me, what numbers can we not put in for x? Okay, we can't put a negative. The square root of a negative was imaginary. So where would this graph start out at?
1.
Okay, at the origin, because we can take the square root of 0. Square root of 0 is just 0.
Yeah.
So it starts at 0, 0. What's the next perfect square? Let's only put in perfect squares.
1.
Okay, what is the square root of 1?
1.
Okay, you have to go over 1 and up 1 still. Every single parent function will go up 1 over 1. Every single one of them will, to start with. What's the next perfect square?
4.
So if I can put 4 in, the square root of 4 gives me an output of,
2.
so 4, 2. So I go up how many? Oh, I have to go over how many?
4.
And up how many? What is this similar to?
The curve.
The quadratic, except it's sideways. It's a sideways U. And we're going to talk about inverses later on. I usually do inverses first, but I thought this would be easier or harder for you to understand from a video. So I want to do graphing today. So basically it's half of a sideways U, because we can't take the square root of negative numbers, and it's the same pattern but sideways. So it's half of a sideways U. So remember, square root is kind of like just starting with the elbow going this way. All right, so we got square root function for number 5. So we've got first degree, second degree. What are we missing?
Third.
So we've got f of x equals x to the third. So do you remember from f of x equals x to the third, what kind of function is this called?
Cubic.
Oh, good. You guys are great. Cubic. So we have cubic. So third degree is cubic. Okay, so this one, when you're graphing, you're going to need 8 this way. So for example, if you put 2 in, what's 2 to the third power? So the output, so on the y's, so I'd go this way. Your x only has to go to 1 and 2, or negative 1 and 2, but you need to go up to 8. So when you're planning out your graph paper, just FYI, and negative 8.
I gotta make it by twos.
Okay, again, I'm going to show an input-output table just so you see the points. And I would like you to write those, if someone's writing on your notes, write those input-output tables so when you're doing on these on your own, you can see the pattern. So where does this parent function x cubed look like? Or where does it start out at? Okay, the origin, 0, 0. Okay, every parent function we talked about starts at a 0. What are some numbers we can put into this function?
1.
Okay, 1. What's 1 cubed? Still 1. Remember, I said it was 1 away every... So it's 1 cubed. Now look at this one. Let's put in negative 1. What's negative 1 times itself 3 times?
Negative 1.
Still negative 1. So it's not symmetrical with respect to the y-axis. I go to the left 1, I go down 1. It's actually has symmetry, but it's with respect to the origin. Okay, so then if I put 2 in, what's 2 cubed?
8.
2 cubed is 8. So I have to go to the right 2 and up 8 because I'm putting it into something third power. It's perfect cubes away. Instead of here it's perfect squares away, my output is perfect cubes away. So I go over 2 and up 8. Okay, and then if I put negative 2 in, what's negative 2 times itself 3 times?
Negative 8.
Negative 8. So I go to the left 2 and down 8. So what does this one look like? A what? Yeah, it looks like an S. Okay, it's an S-shaped graph. So that's my cubic. All right, so then what we're going to look at, what would undo something to the third power?
Cube root.
Cube root. So our last parent function we're going to look at for number 6 is called the cube root function. It is the cube root, and it is f of x equals the cube root of x. It's f of x equals the cube root of x. Again, this time, because think about perfect cubes. What's a perfect cube here? 8. So you're going to have this graph, but it's going to be inverted. So you're going to need 8 this way. The x. So when you're planning your graph for now, to put it on your graph paper, you're going to need 8 on the x-axis in either direction. And again, I'm going to put an XY table so you see the important points for this graph. And then when we get into transforming them, if we know the pattern, we can use the pattern and just transform them based on the shifting of it. And we'll talk about that in the next video. All right, so where does this graph start out at? Take a wild guess for me.
The origin.
All right, the origin. How'd you know? I know, I told you like 7 times already.
Yes.
It's okay. All right, so what are some perfect cubes?
8.
8. Okay, can we go?
Or 1.
Let's do 1. 1, 1. If I put the cube root of 1 is going to be 1. Remember I said every parent function is 1 away from the starting point. What if I put negative 1 in? What's a cube root of a negative 1? A negative value, and we can do that. The cube root of negative 1 is negative 1. Because what times itself 3 times is a negative, so it will be negative 1. So it's just like this one, but it's going to be sideways. And then what are the other 2 perfect cubes we're going to need?
8.
And
Negative 8.
and negative 8, which is 2 and negative 2 respectively. So go to the right 8 and up 2, and it's right in my table, but we'll get the shape of it, and go down 2 into the left 8. So this is where I'd say it's a sideways S. So this was your sideways S shape. Okay, so before I would do a little more charades if everyone was here, but after, so what I will do, looking everyone, I would like you just to look at me. So I'll be the center of attention for a moment. Don't look at your notes. So if I create some shape, you've got to tell me, just shout it out, everyone, okay? So here we go. Wait, I gotta do it straight.
Linear.
Okay? Wait, let's do this.
Quadratic.
Touchdown!
Quadratic.
Okay.
Absolute
Absolute
value.
value.
Okay, all right. I gotta work on this one. Oh wait,
Cube
cube root. How about this one?
Square root.
Like this. Walk like an Egyptian.
Oh, wait.
Cubic.
Wait, this one. Cubic. Long S. This one. Walk like an Egyptian.
Cubic root.
Cube root again. Okay. Touchdown.
Quadratic. Absolute value.
All right. We good with what? We're good. Oh, wait. I forgot. Thank you, Hannah. Wait, this one with my hinge at my elbow. My elbow's the origin. What is it? I can't hear you.
Square root.
Oh, perfect.
Why is it
All right.
square root doesn't